There are these creatures that came from off-world. These are outsiders. NASA, well known for its critical disclosures, has uncovered that this new planet isn't simply enchanting considering the reality of its size and area, yet likewise because it shows lights that have every one of the stores of being phony. Are we, for all intents and purposes, revealing insider real facts that could change our view of the universe? Could this revelation mean there is life on various planets? Accompany us as we look at NASA's enchanting disclosures and reveal the reality regarding these astounding lights. In 2007, NASA delivered the Dawn spacecraft with a mission to investigate the most enchanting objects in our nearby planetary gathering. Dawn was phenomenally outfitted with 3 ion motors, permitting it to undertake an outstanding journey. Dawn's outing began with a 14-month investigation of Vesta, the second largest asteroid in the belt. During this time, Dawn sent back detailed pictures and information revealing Vesta's bewildering surface and various land accounts. In the wake of finishing its primary objective at Vesta, Dawn set out on the second and maybe most enchanting piece of its undertaking, a close assessment of the dwarf planet Ceres. In light of its ion motors, Dawn had the option to leave Vesta's orbit and embark on a mission to reach Ceres, an accomplishment that traditional chemical drive would have found challenging. These motors provided a steady, gentle push, enabling Dawn to travel immense distances efficiently and enter a stable orbit around Ceres. First found in 1801 by Italian stargazer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For quite a while, it was considered the littlest dwarf planet in our solar system until its renaming in 2006. With a diameter of around 950 kilometers, Ceres is the largest and most massive body in the asteroid belt and one of the most interesting due to its unique qualities. As Dawn advanced toward Ceres, researchers anxiously anticipated the first detailed photos of the strange world. They saw bright spots dissipated across its surface, most strikingly in an enormous cavity now known as a crater. These brilliant spots sparked prompt interest and theories among standard researchers. Before Dawn's mission, the best image we had of Ceres was a hazy, low-resolution photo taken by the Hubble Space Telescope. Scientists had barely any familiarity with this dwarf planet, and the chance of finally getting a close view was thrilling. What secrets would Ceres uncover? What new discoveries awaited the mission? Dawn vowed to enhance our understanding of the nearby planetary body's evolution and the role of water in shaping planetary bodies. The bright spots on Ceres were unlike anything seen on other asteroids. They appeared to be made of highly reflective material, possibly salts left behind by sublimated water. This led to the possibility of cryovolcanism on Ceres, a process where volcanoes erupt with water or briny fluids rather than liquid rock. However, what exactly are these mysterious lights, and what do they reveal about Ceres? Might they be proof of ongoing geological activity or something much more extraordinary? Ceres stands apart from other celestial bodies in the asteroid belt because of its size, mass, unique composition, and potential for water and ice. Unlike most rocky asteroids, Ceres has a composition more similar to a comet, suggesting it holds more secrets about the early solar system than we ever imagined. Following 2 years on its journey, the Dawn spacecraft finally began its approach to Ceres in mid-2015. This moment marked a significant achievement in the mission, as Dawn was able to deliver humanity's first close-up views of the largest object in the asteroid belt. As Dawn moved closer, the images of Ceres became increasingly detailed, offering brief glimpses of a world previously shrouded in mystery. The first pictures revealed a surface dotted with craters, indicative of a long history of impacts. However, it wasn't just the pits that caught the attention of researchers and space enthusiasts alike. Among these features were odd bright spots that stood out sharply against the darker, rough landscape. As the pictures continued to improve in resolution, scientists buzzed with speculation about the nature of these bright spots. Were they ice patches reflecting sunlight, or could they be something much more vivid? Hypotheses ranged from mineral deposits to potential indications of cryovolcanic activity. Closer examination revealed that the brightest spot was not a single substance, but rather possibly a combination of several distinct areas. This discovery only deepened the mystery, The speculation that these were deposits of salts left behind by sublimating water gained traction. This would suggest that Ceres had, or still has, some form of geological activity capable of moving water or briny fluids to the surface, where they quickly evaporate, leaving behind bright reflective deposits. These discoveries challenged existing notions about Ceres, demonstrating it to be a more complex and dynamic world than previously thought. The presence of such features raised the possibility of subsurface water or briny pockets, which could have significant implications for our understanding of the potential for life in our solar system. But what makes Ceres noteworthy compared to other planets? Ceres is a fascinating world, often described as a cold planet with a harsh yet penetrable surface. Unlike most asteroids in the belt, which are made primarily of rock and metals, Ceres stands out due to its unique composition. Its surface is a mixture of water ice and hydrated minerals, including clays and carbonates, which gives it a significantly less dense structure compared to its neighbors. This composition suggests that Ceres has a substantial amount of water. The surface layer is rough but permeable, with ice and other volatiles trapped inside. This cold characteristic is more reminiscent of a comet than a typical asteroid, indicating a history that may have involved a mix of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals even more intriguing aspects of its structure. The dwarf planet is believed to have a differentiated interior, consisting of a slushy mantle and a core. The mantle is thought to be rich in water ice, making up around half of Ceres' total volume. This mantle, possibly a blend of rock and salty water, surrounds a core that might be composed of denser material, potentially silicates. The presence of such a large amount of water ice suggests that Ceres may have once held liquid water, especially if its core was warmed by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises fascinating questions about its potential for geological activity and the role of water in its evolution. However, that is not all. The discovery of ammonia clays on Ceres suggests that the dwarf planet may have formed in a colder part of the solar system before migrating inward. The presence of ammonia lowers the freezing point of water, supporting the idea of subsurface brines. These insights into Ceres' structure and history not only enhance our understanding of this captivating dwarf planet, but also provide significant clues about the processes that govern the formation and evolution of icy bodies throughout the solar system.
Cryovolcanism is a fascinating and somewhat exotic geological process, particularly when compared to the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that erupt liquid rock, cryovolcanoes, also known as ice volcanoes, erupt volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the very cold conditions where cryovolcanoes are found on Ceres. Cryovolcanoes operate by allowing water mixed with dissolved salts to reach the surface. When this briny water interacts with a vacuum of space, it rapidly sublimes, changing directly from a solid or liquid state to gas, leaving behind bright reflective salt deposits. These salt deposits form the mysterious bright spots seen on Ceres' surface. The most famous of these bright spots is located in a crater known as a crater, specifically in an area referred to as Spot 5. This region has drawn significant attention due to its high reflectivity and unusual mists observed by the Dawn spacecraft. These mists are believed to be caused by the sublimation of water, suggesting that cryovolcanic activity may still be ongoing or may have occurred relatively recently. Additionally, Ceres has several other bright spots, each with its own unique characteristics. These spots are not limited to one region but are distributed across the dwarf planet's surface, indicating that cryovolcanism may be a widespread phenomenon on Ceres. The presence of these bright spots highlights the extraordinary nature of Ceres and raises important questions about the potential for life in our solar system. The dynamic and evolving nature of Ceres challenges previous assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, an abundance of surface features began to emerge. The surface of Ceres is pockmarked with various craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, showing an old surface that has been subjected to various impacts over billions of years. Others are better preserved with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is fewer than initially anticipated, indicating that geological processes may be renewing the planet and erasing evidence of older impacts. One hypothesis is that Ceres' icy crust allows for a type of cryovolcanic resurfacing, where subsurface materials periodically well up and cover older features. This ongoing geological activity suggests that Ceres is not a static world, but one that has been, and may still be, actively evolving. Additional evidence of surface deformation on Ceres comes from the observation of cracks, grooves, and ridges on its surface. These features show that Ceres' crust has experienced significant stress and stretching. Some of the cracks appear relatively young, possibly only a few 100 million years old, suggesting that the crust is still somewhat dynamic. The ridges and grooves on Ceres likely formed as the surface was stretched and pulled apart, while lines of mountains and compressional ridges indicate areas where the surface was pushed together. These contrasting features provide a glimpse into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal pressure or upwelling of materials, potentially linked to cryovolcanism. This feature, along with the extensive network of cracks and ridges, points to a dynamic and evolving surface. Dawn's mission has also uncovered intriguing surface compositions beyond the bright spots and reflective salts. NASA's data has revealed a range of surface materials that are crucial for understanding Ceres' geological history. For example, specific regions on Ceres display a dark, fine-grained material that stands out in stark contrast to the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, adding another layer of complexity to Ceres' composition and suggesting a potential for prebiotic chemistry. The connection between these materials and the icy surface could play a role in the chemical processes occurring on Ceres. Furthermore, the discovery of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found in carbon-rich mixtures. These discoveries are particularly exciting because they suggest that Ceres may have conditions suitable for the development of more complex organic molecules. The presence of these compounds opens up possibilities for life, or at the very least, the building blocks for life being present on this dwarf planet. Another astounding feature is the large number of mysterious dome-shaped structures on Ceres. These domes, some reaching heights of up to 6 kilometers, are believed to be the result of subsurface processes pushing material through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or internal pressure driving materials upwards. Understanding these formations is crucial for unraveling Ceres' geological history and its internal structure. Moreover, the gravity data collected by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of different layers within the dwarf planet, indicating that Ceres' interior may have complex structures, including a possible subsurface ocean or briny pockets. These revelations are critical for understanding Ceres' thermal history and its potential to support conditions favorable for life. Overall, the Dawn mission has not only expanded our knowledge of Ceres, but has also transformed our understanding of small celestial bodies in the solar system. As more data is analyzed, researchers hope to unravel the mysteries of this dazzling world and its potential to provide insights into the broader processes that govern planetary evolution and development. As Dawn continued to send back data, scientists focused on the implications of its findings, particularly regarding the potential habitability of Ceres. The presence of water ice and organic compounds suggested that Ceres might offer environments conducive to the development of life. Researchers were intrigued by the idea that if such compounds existed in significant amounts, Ceres could serve as a unique laboratory for understanding the origins of life in our solar system. The study of surface features and geological processes on Ceres revealed that it is not just a frozen relic of the early solar system, but a dynamic world with a complex history. The variety of materials detected on its surface indicated a rich geological past influenced by internal processes. This complexity suggested that Ceres might have undergone significant changes over time, possibly driven by heat generated from radioactive decay or the pressure of its own ice. Additionally, the study of Ceres raised questions about the role of smaller celestial bodies in planetary formation. The interactions between ice, rock, and the solar environment might provide insights into the building blocks of larger planets. Investigating these interactions helps scientists understand how materials necessary for life might be distributed throughout the solar system.
Ceres' unique position within the asteroid belt also makes it a prime candidate for future exploration. The discovery of possible cryovolcanic activity and the potential for subsurface oceans could encourage further missions aimed at unraveling its secrets. Future spacecraft could focus on in-situ analysis of the bright spots, providing more data on their composition and the processes that created them. Moreover, the technological advancements showcased by the Dawn mission highlight the importance of continued investment in space exploration. The mission's success demonstrated how innovative engineering and collaboration can yield groundbreaking discoveries. As space agencies consider future missions to icy bodies, lessons learned from Dawn will shape strategies for landing, sampling, and analyzing other celestial environments. Scientists are also considering the implications of Ceres for understanding similar bodies beyond our solar system. The ongoing discoveries inspire astrobiologists to rethink the potential for life in diverse environments, broadening the search for extraterrestrial life to include not just Earth-like planets, but also icy worlds that may harbor the conditions necessary for life. In conclusion, the findings from Dawn's mission to Ceres have far-reaching implications, reshaping our understanding of planetary evolution, potential habitability, and the search for life beyond Earth. As researchers continue to analyze the data, the dwarf planet remains a focal point of scientific inquiry, promising further revelations about our universe and its many mysteries.